Today on the stand we have a 1979 911 SC 915 transmission with some shifting complaints. We're going to take it apart, see what it needs.
Like a shovel. Studs came out again. Done a lot. On his car, that's happened a lot. Bolt rust to the stud.
Yeah.
Wow.
It's normal, I would say. Oily, gooey, smelly. Find the lifting tabs through the debris. Ooh, that's thick. Oh, it undid.
Oh. Already.
Next. Finding the bolts. I know they're in here somewhere. It's easier to undo it now than when the case isn't held on. I noticed our oil vent isn't installed correctly. This is actually supposed to be angled on like a 45-degree angle. So some of this oil that's on the outside of this transmission can be attributed to our vent being incorrectly installed. Some of it, not all of it. Synchro's pretty much done. First gear synchro done, first gear dog teeth done. Second gear dog teeth don't look too bad, but I think I'd probably, reassess once it's all apart. Synchro's definitely worn out. Pretty even smattering of synchro material throughout the top of the transmission. I would say normal. Third and fourth, seeing a lot of gear changes up there. Third gear is not uncommon, but fourth is. And you can see first gear. See how the tops of the teeth are all gone?
Oh, here?
Yeah. Sharp edge is all gone. So it's going to need probably a slider, definitely first gear synchro. Ooh. Bearing, definitely seen better days. Both bearings seen better days. So now I just go see what it's like inside the case. Nuts are going to fall. Do need to recover those because these are. Yeah, the bearings are definitely showing signs of wear. Definitely had some debris go through them. Yeah, I would do second gear dog teeth. They're just not pristine. First gear synchro's definitely done. Yep. So let's get the shim off of here. Oh yeah, that's really bad. I got side to side movement, so the case is going to need to be machined. Wow, that's got a funky wear pattern in it too. Yeah, that's really loose. Top one feels tight. Definitely the bottom one is spun, so we're going to have to overbore it and sleeve it. Yummy. One thing, all those studs coming out makes the cover easy to come off. That one wasn't spun in the case.
It's good.
That one's super loose. Look at that. Look at how much vibration that has.
That's bad.
Yeah, it's okay. We can fix it. The magnets right here, so as these pass by our inductive sensor, it's what creates the speedometer signal. Yeah, these have got plenty of wear. You can see all the score marks. I can catch my fingertips in it, fingernails dragging over it. Nothing catastrophic, but definitely time for a refresh. Don't see anything horrible on the gear set. Okay. One of our last 915 videos, we had somebody comment that we didn't show enough detail with the reverse fifth gear lockout detent. This is something where it can be overlooked. It's a good idea not to. Our cleaning process doesn't allow me to overlook it because this is going to be vapor blasted and tumbled, so we need all of the moving parts out of it. Down inside here, you'll see there's a roll pin here, there's a spring, there's a detent, a little transfer rod. We need to get all of those out. There's 2 roll pins, there's this one here and this one here. And what they do is they hold that spring in place. You'll see it all when it comes apart. To get it out, you've got to use this little Pinion cap here. We usually like to replate those anyway. This one's nice and rusty. I'm just going to pull that out, and then we'll pull out all of this detent system and look at it on the bench. So there's a pin. Okay, I'm just going to drive out the first pin. So there's my punch sticking through. There's some spring pressure under it right now. Here's my roll pin that came out. When I pull this, it's going to release that spring pressure, so I'm just putting my thumb over here. Pop. And it didn't pop out, which is great. So when this plug was driven in, it creates a little burr, and my detent doesn't want to come out, so I'm just using my bearing scraper just to remove that burr. There's my detent, part of my spacer. These get filled up with synchro material, so they get pretty nasty in there.
Just the spring?
Yeah. I'm going to pop that. Yeah, shine it down there.
Oh, there's the spring.
You can see the spring I've got sticking out right now, and it's just doesn't quite want to play ball and come through the, there it is. So there's the spring. Then we've got one other detent, which I'm going to take out. So there's a roll pin. Gummed up in there so it doesn't want to move. Okay, so this one was really jammed in there, and what happens is you get a lot of synchro dust and crap that gets down inside this hole, and it just jams all of this up, and I really had to work at it to free it up. So it's important when you're doing a transmission to pull this stuff out. I kind of do it as second nature. I've always done it on every transmission job. A lot of people see these caps here and they go, oh yeah, you can't get in there. Well, you just tap them out and then they tap back in when you finish. There's one more on the actual case body. We'll show you that when we get to it. Right now I'm going to pull the bearings on this and continue cleaning on this particular piece of case. Okay, so we've got probably 4 hours in cleaning this housing just to get it ready for real cleaning. This one was really caked on with stuff. It had a lot of leaks. The other issue that we had was our main pinion bearing, which is showing a good bit of wear on the inside. But this one that sits in this housing, it was spinning and actually had side-to-side movement. So what we're going to do is we're going to actually overbore this. I'm going to press in a sleeve and then rebore it to give us the correct crush on the bearing. This is a common problem on the 915s. The other thing that we want to look at is high spots all across this area. So once I've fixed the bearing sleeve issue, we'll pull all these studs before it goes in the mill. But we'll actually put a dial gauge across this area and make sure it's flat and parallel to this surface. That way when we set up our shim pack for the pinion, we know it's going to be square and it's going to be reliable. If we look inside the housing, what we can see here is the high and low spots. You can see where the bearing wasn't even touching right here, but it had contact here, it was spinning against here, same over here. It looks like the housing is probably a little bit egg-shaped because we have more contact down here and almost nothing up here. So the fact that these aren't held well to begin with doesn't help the fact that they tend to spin. And more of these we're seeing are getting worse and worse. So something to pay attention to. So now I've got all my case parts cleaned. I got my bell housing in my tumbler. We're going to go to work on our input shaft first. This is 3rd and 4th gears. So we're going to get this, undo the nut here, press the gears apart, clean everything, have a closer inspection of our dog teeth, new synchro rings, inspect the slider, new bearings on and off. You can see on the end here, this bearing's had quite a bit of stuff going through. You can see those lines right there. A certain amount is normal wear and tear, but this one is at the point now where if we don't replace it now, it will become clumsy. Okay, so looks like one of our bearing cages has split and the roller was just hanging out, so we'll have to pick up a new one of those. Synchro ring showing normal signs of wear. Normal wear and tear. So I've washed everything right now. I also hit it with a solvent because you want these perfectly clean when they're going back together. So I've just put a spacer in our 1st gear with our thrust washer on. We picked up a new bearing for 2nd to 3rd gear. We'll get that, get the new synchro rings on, get the new bearing on, get it all back together, and then tighten the shaft up. See that plastic race. Okay, so we got our gear set reassembled. I got my new nut. It has our Loctite already built into it. And I'll tighten that down and torque it up. And once it's torqued, we'll pin it. Everything spins nice. Nice and locked up. Synchro. So there's our rebuilt input shaft. Alright, so the last thing I'm going to do is check my shaft run out. I've torqued the nut down. I haven't peened it yet in case I need to undo it. Sometimes you need to loosen these off and retighten them. But what we want to do is I got my dial gauge set up right on where the pilot bearing runs. The specification on this is up to 0.1 of a millimeter is fine, and you will always have some run out here. If it is greater than 0.1 but not bigger than 0.3, you can straighten the shaft, and you just use your press to do it. You figure out where the high spot is, and you'll put it in the press and you'll straighten it between here. So when I look at it, right now this one, I've already spun it over. It's running about 0.9 to 0.1. So it's right in the usable range, which is great. It means I can go ahead and peen my shaft nut and move on to my pinion shaft. Okay, so next up is going to be our pinion shaft. Okay, for this last part, we're going to put a bearing separator right here and put this in the press and press off the last two pinion support bearings. So I'm just taking a good look at my slider. I'm replacing dog teeth on first and second. This thing was grinding, and there's a little bit of damage here. There's also, if we look in the center, right here, this groove actually helps to hold the slider in gear, because when you select, this is moving over, it's working against the synchros and locking into the dog teeth on the gear. And this part right here does wear down, and what will happen is if this actually wears to where it's flat, it'll cause it to come out of gear easier when you step on the gas. So it's a good idea to replace these. They also suffer from wear on the point. So this one's not. First gear is showing signs of grinding. It's got some flat spots. Certainly not the worst I've seen. Gears, the dog teeth, definitely. They've knocked the points off of them. You can see right here on the point how it's flattened out. That should be nice and sharp there. And so that's, and what you're hearing is this part of the gear is actually grinding against there. That's the grinding noise that you hear in the transmission when it doesn't go into gear. Now the synchro is really polished, fairly normal. And what happens when it gets, you can see here that shine on it. When it gets that really good shine, that's because it's wearing against here. It doesn't slow the gear as well. And so when you go to engage, you get that grinding. Second gear, not as bad as first gear. Still showing signs of wear though. Yeah, very worn. It's backwards. Too far ahead of myself. Okay, so we've got our new dog teeth pressed on to first gear and second gear. We've got our new synchro bands. First and second are different in the SCs. This is from 78 on. It's got a slightly different brake energizer band setup. You'll see first gear dark teeth are asymmetrical, but this is a complete band, whereas the earlier 915s just used one side and a different anchor block. Second gear, new dog teeth, new synchro band, and you can see this is a more symmetrical setup as it is braking both directions. So we're just going to put our circlips on, assemble them onto our pinion shaft, and that'll complete our pinion shaft assembly. Okay, so if you feel like you didn't get your gear sets on correctly, you can always put the two shafts together and they should line up nicely with all the gears in the right place. So we're just putting our new bearing outer races into our intermediate housing. Putting a snap ring on, and then we're just going to drive it on there. Locks it in. So now we're going to reassemble our reverse fifth detent system. We showed it coming apart. I just wanted to show it one more time. When we put this back together, there's a couple of things that we have to kind of be aware of when we're getting our roll pins in to hold everything. This one in particular is the groove right here. We want to make sure that this particular pin is located in that range. That's its operating range right there. So if we drive that pin in, let's say I wasn't paying attention, I let it slide all the way in. Theoretically, I could get it right there. Also, if it's not far enough up, if it's sitting up here and we drive the pin in, that's obviously going to be a problem. So I've already cleaned the bores out. Usually want to get down here with a ball brush is what I use to scrub this out. As I said before, it does tend to build up with a lot of debris from the synchros, and our cleaning methods are fairly aggressive, so we could leave material in there, so it's all being scrubbed out. Okay, so I've got my detent pin pressed in, and then when I look down through this hole right here, I can see that I have straight through to the bottom. I can see the detents right here. Probably can't see it in the camera. Okay, and then I've just got a piece of brass. I can check to make sure that the pin is moving freely, which it is. Back and forth. And is retained by the roll pin. Okay, so next, this one takes a little bit more finesse. We're going to drop our spring, our guide tube, and our pin in. And then we have to depress everything and hold it depressed while we get the roll pin in. So, springs in, and then my spacer bushing down. Just going to sit that piece of brass rod on top. So right now what we're looking at is right here is where the guide sleeve is. So I need to compress that using my brass rod, and I'm going to see the brass rod come into the picture right there. And on this particular one, I've ground the end of my rod, So I can press it down and hold it and then drive my roll pin. So if you see it opens up, if I let it come back, there's the bushing, press it down, and it gives me room to drive my roll pin in. Okay. Pull the rod out, and that roll pin just drives in until it's flush with this housing. We can put our transfer pin in, and that'll lead straight in. Sometimes they need a little jiggle. And lastly is our detent. That's going to drop in like that. And that's the system. We got to drive our plug back in. We've still got to replate it, so we're not going to drive it in right now. We can check that transfer system if I lift up. We can see right there how that ball has lifted up. If I move it around, I'm going to pull it back, and we see how it drops back down. So the detent system is working correctly. So we're going to pull the side bearings off and get ready to clean up our differential. Just got a two-legged puller and a spacer on here. So just pulled the other side carrier bearing off. These ones are really, really tight. 9 times out of 10 it trashes the shim. And not a lot we can do about it. Let's make sure it's going to move. Okay, so I'm just driving my roll pin out so I can pull all my pin gears out. Pinion shaft. Looks like it's in pretty good shape. Okay, so my pinion gears and sun gears. Now we can go clean these up. And this is just for clean and inspection. These gears can actually look pretty rough too. These only work in cornering. And if you have a limited slip differential, you will have a different setup than this as well. Okay, so I've got everything cleaned up. Everything looks pretty good. A little bit of Scotch-Brite around where my bearings were just to clean off any kind of leftover oil debris. I want to take a look inside at all the bearing surfaces in here, and a lot of it's just running my fingers over it, nice and smooth. Same with our pinion shaft pivot. These are for the sun gears. They run right here. A little bit of scoring on one end right here, but certainly not enough for me to worry about changing. These only work when you're cornering, because one wheel is going to travel a different distance than the other. So not too worried about that. A little bit of Scotch-Brite kind of took off some of the minor scuffing. Same with these are our pinions, these are our sun gears. Just want to look at the thrust surfaces. Any major scoring, you would change them. Any minor little marks, not too worried about it. All of these were good. There was a little bit of weird staining here. A little bit of Scotch-Brite took that off. There's like a little etch there, but I can't feel it with my fingernail, so fine with that. Same with the gear surfaces. You'll notice on these little pinion gears, they're pretty rough compared to, say, a machined forward or reverse gear. And that's, once again, because these things are only working when there's a difference in wheel rotations. So I'm just going to reassemble all of that. Cleaned up my shims, cleaned up my speedometer transmitter. I'll measure my shim pack. This was on my inboard side, outboard side. I usually start with what was in there, especially if it wasn't giving me any noise or major issues. This one, I was able to feel the backlash. It wasn't bad when I pulled it apart. But using new bearings, that can change. So it doesn't necessarily mean that those are going to be right. It's just a starting point. And then we've got to get it into our housing, measure our preload settings on the tapered roller bearings. And then once we've set up our pinion depth, we've got to check our backlash. Another thing you want to do is right here is our sizes. Optimum backlash on this one is 0.15, a little bit hard to read on this one. The other number right here is the matching gear set number. So if you wanted to confirm, you can look at the pinion and you're going to have that same 3862 number there, which says it's the matching gear set for our crown wheel. Okay, so I've recorded my S2 and S1 bearing thicknesses, shim thicknesses, and just tapped on my new tapered roller bearing. Got to flip it over and tap the other side on, and then this is ready to go back into the housing and start adjusting. So today we have in our mill our 915 transaxle. This is the front bell housing, and this is the bearing that was spinning. So what we're going to do is we are going to machine that out. I've got a sleeve that I've machined, and we're going to press in a steel sleeve and then remachine it to give it the right interference fit for our bearing shell. One of the other things I want to check with these is over the years, these studs, which is what holds the pinion and input shaft to this housing, they can tend to kind of pull up a little bit. So I've got my straight edge on, and already I can feel there's a little bit of a rock there. Using a 3/1000 feeler gauge, which is 0.076 millimeters, I can easily fit my feeler gauge underneath this area. Same when I come to the other side. Just trying to go across the studded area. Also 3/1000 feeler gauge goes straight under, so that's 0.075 of a millimeter. We're usually looking for no more than about 0.025 of a millimeter, or about 1/1000th of surface distortion here. So once we're done machining our bore right here, and we've pressed our sleeve in, is I'll take an end mill and I'll just surface just this area. We don't want to take it off of this area because that'll change where the intermediate housing comes in and bolts to it. We can't change that dimension. This one we can readjust with shims, and I'll probably take 0.1 of a millimeter off of this surface. So I'll just make sure I catch here. There'll be a small lip here, nothing too bad, and around here pick up all of the selector fork areas. So this is the steel sleeve that we've got machined up. This is going to be pressed into here. Right now it is about 2 millimeters oversize, and we'll set up with our boring bar. We'll bore this out, press the sleeve in, and then machine it to suit the bearing. I have my new sleeve installed and tapped in very nicely. Now we're just going to remachine our sleeve to our bearing diameter. So I've measured the bearing outside diameter. It measures 79.996. We're looking for about a 0.05 of a millimeter interference. So I'm going to machine this out to 79.95 to 94, somewhere in that range. Okay, so we've finished machining our bore. Measured it with my split bore gauge. If we take a look at our mic, we've ended up at 79.948. So I'm pretty happy with that. I don't want to take another cut off of it. And when I just test with a bearing ring, bearing in mind this is very dirty, it's sitting on there nice. It's ready to tap in. And I think that'll give us a nice crush and definitely retain this a lot more. So I'm just going to clean off the job, change tools. We're going to surface this. We're going to take about 0.1 off of this material right here, and we'll be ready to move on and clean it and get it into assembly. Okay, so we're all cleaned up. Everything's nice and flat. 0.1 cleaned it up really well. We had a deviation of 0.75 millimeters, sorry, 0.075 millimeters, about 3 thousandths. That cleaned everything up nicely. So now we're ready to get this out of the mill deck, do our clean, put a chamfer on here, punch our bearing in, and get ready for reassembly. Still got to clean all my threads. A lot of cleaning to go on this case next. Okay, so we have our transmission front case all cleaned, our bearings all tapped in. Everything fits very nicely. I did a test fit with our input shaft and pinion shaft, just checked our gear backlashes after machining a new bearing support. Everything feels really good, so now we're ready to do pinion depths. I still need to put the back intermediate housing on to do this. I've got my pinion bolted in, and our pinion depth is our distance from the nose of the pinion to the center line of the differential. So we'll be using our VW 385 tool for that. Okay, so we've got our intermediate housing temporarily bolted on. We still haven't got our studs back from plate yet, so I'm just using a bolt here and a nut over here. And this is to make sure our pinion stays nice and straight. I have torqued our nut here. This is torqued at 260 Newton meters, so that tightens all of the gear sets. And we've got our VW 385 installed and calibrated. This one is an N17, so that's plus 0.17 to our setting. Right now, it is showing me that I am 0.05 in too deep. So a combination of things have happened here. We machined 0.1 on the case. We have new pinion bearings. I did start with the original shim pack because that's just a place to start. And looks like all we got to do is add a 0.05 shim, and that'll bring us right into where we need to be. I just put in a 0.05 shim, and I'm just reloading everything now so we can recheck our measurements. On to our center point with our 0.05 shim. We are exactly on 0, which is our calibration setting. So pinion depth is set. We're going to move on to differential, preload, and backlash next. Okay, so next step is our tapered roller bearing preloads. And once again, I've used the original shim packs in their original locations. So I'm just going to bolt our cover on and see what it looks like and make changes from there. Right now it feels good. I've got a little bit of tension holding it up. And I'm just going to grab some bolts because once again we're waiting on our studs to get finished plating. Feels good. Let's measure our drag. Looks like about 25 newtons. Feels nice and smooth. 22 and a half. Okay, so I need to pull the diff back out. The bearing preload is too light, so I need to increase my shim pack. Right now, my total shim pack is 6.163, which is, I thought was a little bit on the low side, but that's just what was in there, and my bearing drag is wrong. Also, my backlash right now is around 0.32 of a millimeter, which is way too much. So I'm just going to start from scratch, recompute everything, and go again. Okay, so I recalibrated my shim pack, and right now my bearing preload is sitting right at 3.5 Newton meters, which is nice, right where we need it to be. And I achieved that by adding 0.1 of a millimeter to my total shim pack. I also made a change from my S2 to S1. I took 0.2 from S2, moved it to S1, so now I'm going to check my backlash next. Okay, so for backlash, now moving it by 0.2, I have 0 backlash. I'm not even going to finish bolting it up because we don't want to bind the ring and pinion, but I can feel that going in. There's nothing there. There's actually a little bit of load on my pinion. I haven't even got the whole thing bolted down. So I'm going to have to pull it out again, and this time I'm going to have to split it by 0.1. And this is the small adjustments you got to keep doing with these. So you end up pulling these bearings on and off a bunch of times, or you can. Hopefully on the next one, since now we know we got preload is good, as long as I keep my shim pack total, I think adding 0.1 to the S2 and subtracting from S1 should get me right where I need to be. So one of the things we just noticed, and this is common for when you're doing this job, because you kind of wash things up, but until you get everything assembly clean, you can't always see everything. So this one has some wear. This is the 5th reverse slider hub. And what we've got is a large wear part on this drive dog. Also on our 5th reverse slider, we also have a lot of wear in the slider itself. So the only way that's really going to happen, because normally we would have a 5th gear on here. I'm just going to slide this on. So when it's engaged, when it's in, not in 5th or reverse, it's going to be sitting right here. But what's going to happen is when this engages into 5th, now we have this huge backlash right here because of that wear. Whereas if we move it out, we're still going to have some. And what this is, it's about double what it should be. So these two parts, even though when we first looked at them, didn't really show anything amazingly bad, once I was able to scrub everything and get it clean, now we're seeing the wear here and the wear here, so both of these components will need to be replaced. Okay, so I've pulled all of my gear sets out so I can do my final assembly. My differential's all set up. My backlash is sitting right at 0.15. My bearing preloads on my differential side bearings are right where we need them. We've got our pinion depth shims all in. Pinion depth came up right on the money, which was awesome. I've already put in the detent and re-driven in the plug here. This is the interlock detent. You can see it. If you look right down there, you'll see it kind of sticking through the bottom there. And so I've dropped that in, and now we're ready to start putting this transmission all the way back together. Okay, so I have both of my detents installed, and so my shafts are in the neutral position. Everything's still loose on my shift forks and selectors. And what we're going to do first is we're just going to adjust the position of the shift forks. Now you need the jig on to support the shafts, otherwise they'll drop down and your adjustment will be off. And we want to, when we adjust these, center the selector in between the two synchros. And then we're going to tighten it down there. That's my 3rd, 4th adjustment. We're going to do our 1st, 2nd. Okay, the last thing was setting up our shift forks on the intermediate housing is our 3rd, 4th selector fork, or selector gate, which is this piece right here. And what we want to do is I have my feeler gauge set at 2.5 millimeters. Just going to slide that in. The clearance there should be 2 to 3 millimeters, so I just kind of picked the in-between spot. And then I've tightened the nut on the bottom to 25 Newton meters. So when I pull this out, you'll notice this has some flex back and forth. What we don't want it to do is get so close that it touches here, because it can bind when you're trying to shift, or it will try and shift 2 gears at once. So for example, if you were going for 4th gear, it could also theoretically try and pull that selector into 1st, which would balk the transmission. Yeah. Okay, so we've got our intermediate housing on, and the whole time you're always rotating and moving stuff, feeling it. At no point should you just be putting this together without moving any shafts. We find stuff all the time that's put together and it's so tight and nobody turns anything until something breaks. Guide sleeves in, new O-ring, new seal on the inside, new screws, hold it in. Just lubricating our clutch shaft. Okay, so we've got our fifth gear, synchro gear and drive gear installed. Our reverse idler is sitting. I haven't got my hub on there for the selector yet. I'm going to tighten my input shaft nut. I have my locking tool installed. And then this one we want to look and see how close we are. It gives us a range to get our roll pin in to lock it. So it looks like I'm closest to this one. I got to go a little bit further. Yep, definitely the closest one. Perfect. All right, so we were able to find a good used guide sleeve for fifth reverse, and I just want to show you the difference there, where here's the original, has quite large lift there, and here's a good used one. It's got some very small markings, but nothing like that issue that we were facing there. So we're going to get fifth gear, fifth reverse wrapped up. Get our collared nut in. Okay, and my special tool to lock up okay, we're just going to pin a nut. Reverse idler gear back on, which I had to take off because it was in the way. O-ring back on. Then the last thing we got to do is set up our 5th reverse slider. This is the 5th reverse slider that we got. This is actually a good used, which is in really nice shape. These have really exploded in cost. This slider now is over $800. We can see the wear on our original one is right down here in this section. Same wear pattern that was replicated on the old support sleeve right here. So this one, we can look at the difference. Nice, clean, no excess wear going on at all. Okay, so when we're setting up 5th and reverse, there's 2 things we want to pay attention to. We've got to be careful that we're not impacting here, so we can't be too far away from 5th. And then as we slide it forward, we've got to make sure we're not too close to the 5th gear synchro. So I'm usually gonna split the difference. I want my dog teeth just looking like they're about to contact on that synchro, but they're not. And I also want to see a good air gap of separation here between my slider and my reverse idler gear. So where it's sitting right now is about where I want it. I'm going to torque our nut to 25 Newton meters, and we're ready to put the back cover on. I'm just going to put some silicone grease, no sealant on the O-ring. We want it to move inside the housing. The other thing, since I have my backup light in, I've got my reverse pin as well. If you do forget this, it's not a major deal. You can access it by taking the switch out, and it works right on this roll pin here. But I just put a little bit of grease on it, so when I'm moving the housing around before I install it, it doesn't pop out. And the other thing I want to do is apply some silicone grease to my shift sleeve, or shift rod. I also deburred this so there's nothing to catch the seal. You got to be careful. Sometimes these will be kind of burred up from the tapered screw going in. And we're going to put a little bit more silicone grease in that seal.
Will it affect the electric contact, or is it in grease?
No. Electric side of it is completely separate. Okay, I'm just going to slide that on. Feel that seal, nice. Pins in place. Nice. Okay, that wraps up our 915 transmission. I got to put the rear cross member on, and got my little zip tie piece to go in there, but other than that, that wraps it up for this 915 transmission.